Hello everyone, my name is Will Matlock and my partner's name is Dominick, and in this video I'll be going over our Reynolds experiment for a measurements lab class taught by Dr. Patki. Reynolds number is a dimensionless value that is used to represent the motion of fluid flow. Whenever Reynolds number is below 2100, this represents laminar flow. Whenever it is over 2100 and under 4000, this represents transitional flow. And anything past 4000 would be turbulent flow. Reynolds number is calculated by using this equation, where Reynolds number equals the density of the fluid times the velocity of the fluid, and then times the diameter of the inside of the pipe that the fluid is flowing through, all divided by dynamic viscosity of the fluid. Our values that we will be using for this experiment are fixed, except for the velocity. Here we're using the diameter of the inside of the pipe, which is 5/8 of an inch, which can be converted into 0.015875 meters. And for the dynamic viscosity and density, we are taking values from water at 28 degrees Celsius. The velocity will change per trial, so we will calculate those later. In this first image, you can see our entire setup. On the left, there is a bucket that holds fluid. At the bottom of the bucket, there's a hole cut out, matching the outside diameter of the pipe that we're using. This pipe runs along over the chair and into a bucket that catches the liquid. In the second image, you can see that there is an inserted syringe, which we use to inject dye into the fluid so we can visualize the fluid behavior. And at the end of the pipe, into the bucket, you can see that we have a brass mate that is used to connect the pipe to a ball valve that we are using to change the flow of the fluid. For trial 1, we calculated the velocity to be 0.003626 meters per second. And with this number, we calculate Reynolds number to be 67.5. In this video, you can see the fluid is flowing very slowly. This flow is laminar. For our second trial, we calculated the velocity to be 0.011832 meters per second. And with this number, we calculated Reynolds number to be 220.1, which means it's also going to be laminar. In the video, you can see it is flowing slightly faster, but it is still laminar. For trial 3, we calculated the velocity to be 0.132953 meters per second. With this number, we calculated Reynolds number to be 2473.2, which is in the transitional flow range. In this video, you can see that the fluid is flowing at a faster rate of speed, and it disperses into the fluid later on down the pipe. This flow is transitional. For trial 4, we calculated the velocity to be 0.260424 meters per second. With this number, we calculated the Reynolds number to be 4,844, which is in the turbulent flow range. In this video, you can see that the fluid disperses quickly and the fluid is flowing quickly. This flow is turbulent. For trial 5, we calculated the velocity to be 0.323861 meters per second. So the Reynolds number is 6,024, which is in the turbulent flow range. In this video, you can see that almost instantly the dye disperses throughout the whole pipe. This has been my and my partner's project. If you have any questions, feel free to leave them down in the comments.